Hello, everyone. Thank you very much for joining us today for the Innovation for Cool Earth Forum, the 10th annual meeting. Now the co-hosted event by UNIDO, making just transitional changes towards deep decarbonization in steel and cement industries, how to stimulate supply and demand for low to zero carbon products, shall commence. First, I would like to introduce the moderator, Mr. Suzuki Yoshinari. Mr. Suzuki Yoshinari is Industrial Development Officer, Division of Decarbonization and Sustainable Energy, United Nations Industrial Department Organization. Now, I would like to hand over to Mr. Suzuki.
ありがとうございます。Thank you very much. こんにちは。Good afternoon. My name is Yoshinari Suzuki, Industrial Development Officer in the Division of Decarbonization and Sustainable Energy at United Nations Industrial Development Organizations. And welcome to UNIDO side event. And thank you very much for your participation to our side event on industrial decarbonization, particularly in the cement and steel sector. So let me brief you firstly about my organization, UNIDO. So UNIDO, United Nations Industrial Development Organization, is a specialized agency of the United Nations with a mandate to promote and accelerate the inclusive and sustainable industrial development. And UNIDO has 171 member countries, and we provide support through their technical cooperation, policy and research services, and normative and standard-related activities, as well as fostering international cooperation for the knowledge and technical transfer, particularly to the emerging countries and developing countries. So today's side events focuses on industrial decarbonizations in steel and cement industries. And actually, I'm a bit nervous now because I saw the other side events and also the discussion of ICEF, and I just thought that other events are pretty great organized, and this great interesting discussions they had. So I'm not sure I can moderate so well like them, but at least I do my best. But at least we have distinguished and excellent speakers and panelists kindly remotely joining from all over the world to share and discuss the industrial decarbonization. So I hope that you will enjoy our side events. So let me firstly brief you about today's side event, because today's side event is composed of two parts. First part is a scene-setting presentation provided by Dr. Chris Bataille from the Columbia University Center. So he will make a presentation to give you the big picture of the current global context and the trends of the industrial decarbonization and the challenges and the possible solutions to accelerate industrial decarbonizations. And then, as a second part, we will invite 4 panel members from private sector and industrial associations working on industrial decarbonization. And we will discuss what are the challenges they are facing in their day-to-day activities and what their views on the necessary enabling conditions to promote the industrial decarbonization. So before going to the panel discussion, let me quickly give you the background information about today's side events, like why we need to talk about the industrial decarbonization, focusing on cement and steel sector, and what UNIDO has been doing on this area. So the materials and products produced by heavy industries like steel and cement play a key role in our lives. As these industries provide essential goods and services, the demand for raw and refined materials from these heavy industries has risen substantially in the past decades, and it will be further increased with emerging economies' industrialization. And abatement in heavy industries has huge potential to address climate change because of its scale of emissions. For example, industrial emissions are responsible for 30% of carbon emission worldwide. Particularly steel and cement industry represent around 15% of global energy-related CO2 emissions, which is huge, right? And the requirement of continuous high temperature heat for the production of these materials demands a considerable, huge amounts of energy that remains today largely reliant upon fossil fuels, as pointed out in the this morning's side event organized by Bloomberg and EF. So, and moreover, the chemical process involved in production, particularly for cement making, an additional source of emission. So this is one of the unique characteristic of cement and steel sectors. And despite the growing range of promising low carbon technologies under development, private sectors and companies lack incentive to invest in these in the commercial scale plants at the necessary scale and the pace. And in this context, UNIDO has worked on this issue through its projects and programs in the world. For example, UNIDO and the Clean Energy Ministerial launched in 2021 the Industrial Deep Decarbonization, we call it IDDI, the largest and most diverse coalition of the government and private sector working together to decarbonize heavy industries, starting with cement, steel, and concrete. And this IDDI aims to stimulate the demand for low carbon materials through green public procurement by harmonizing global standards that define what low carbon steel, cement, and concrete is, and how to account for embodied carbon. And also by developing a global framework with publicly accessible data that is easy to navigate using tailored digital tools. And also by setting up a globally recognized target for public procurement of green steel, cement, and concrete. So, with this backdrop, today's side event is closely related to UNIDO's such activities because we will discuss the current global trends in the sectors, including ongoing initiatives towards decarbonization in the steel and cement industry to enhance understanding on possible harmonized measures and enabling conditions, as well as facilitative roles which international partnerships and cooperation can play for the industry to take exact actions. So now let us turn to the next agenda item. So we start the first part of the side event, the setting presentation by Dr. Chris Bataille. So Dr. Chris Bataille is Adjunct Research Fellow at Columbia University Center on Global Energy Policy. So he will be making scene-setting presentation on the global context and the challenges and possible solutions, technologies to accelerate industrial decarbonization. And we have his pre-recorded video presentation. So the ICEF secretary, could you please start the video presentation?
Hello, everyone. My name is Chris Bataille, and I'm here today to talk to you about a just transition to net zero in the global steel and cement sectors. First, the Paris Agreement changed everything for industry. Before Paris, industry used to live in a cushion under minus 80%. So the rest of the economy would go to minus 80 and industry carry on doing what it was doing before. Since the Paris Agreement, however, all CO2 emissions have to drop by half by 2030 and get to net zero by 2055 to keep the 1.5 to 2 degree Celsius goal in sight. There is no more cushion, and any facility still emitting past 2055 will have to buy negative offsets at $100 to $300 or more per ton if these offsets are available. Now, why do industrial CO2 emissions matter? Because, taken all together, they are the single largest source of global combustion and process CO2 emissions, and they use 1/3 of utility-produced electricity. The biggest emitters are normally iron and steel, cement and lime, collective other industry, which is mainly for steam, and the chemicals industry. Now, the other industry and non-ammonia chemicals are abnormally low in the chart I'm showing you here, because this is from 2020, the latest sectoral data we have, and it's due to lower than usual demand due to COVID. And as the 2021 and beyond data comes in, we expect those sectors to rebound. So how do we do it? There are 6 broad strategies for industrial decarbonization. First is demand and material efficiency, where we use design and building codes to minimize GHG intense materials. And we expect that about a 25 to 30% of iron and steel and cement and concrete demand can be reduced simply by making architects, structural engineers, and construction companies conscious and aware of the use of these materials and limiting them on purpose. Then there's circularity, which in the practical nuts and bolts terms is more recycling. We want to maximize the high quality metals and plastics reuse and recycling. And this is especially important for iron and steel. Both iron and aluminum actually are potentially infinitely recyclable materials. But if they get contaminated with other metals, and in iron's case, that's copper, then they can be used only for a limited set of end uses. So we want to recover as much iron product from the economy as we can, and we want to separate out as much of the other metal as we can to keep it recycling it through time. Then there's energy efficiency, but because iron and steel and cement and concrete are so energy intense to start with, we tend to have maximized that energy efficiency with the existing processes we have. There are some systemic efficiencies that are available, but to get big jumps in energy efficiency, we need to move to new processes. Now, it is possible to both electrify and fuel switch, to a certain extent, existing processes for both iron and steel and cement and concrete making. There are methods for going from coal to gas for making steel, but to a certain extent, these are limited without some significant process jumps. However, this comes to making big process changes to allow the use of low GHG energy to go from coal to gas down to electricity. And I'll be talking about how we might use hydrogen instead of coal as the primary chemical reductant in iron and steel making. And then we have our backstop, which is carbon management, where we use carbon capture and utilization, bio and air captured synthetic fuels, carbon capture and storage, and potentially carbon dioxide removal to recover those remaining CO2 emissions that we put out in the atmosphere. And also in the case of CDR, bringing down the atmospheric concentration of CO2. How do we make steel and how do we make near zero emitting? First of all, we want to maximize the recycling, typically because we recycle using scrap using electric arc furnaces. If we decarbonize the electricity, then we've largely decarbonized the production of that steel. But currently today, about 25% of steel is made through the secondary or recycled route, and we want to take that up as close to 50% as we can by mid-century. We want to use material efficiency, obviously use as little steel as possible. But after that, we start looking at decarbonizing the core primary iron making process, where we separate iron from oxygen in iron ore. Most of that today is done with coal in blast furnaces. We use coal to make coke and coke to make carbon monoxide. And it's the carbon monoxide that carries away the oxygen in iron ore, leaving elemental iron, which we melt and then process into steel. There is another process that was pioneered in the 1970s called direct reduced iron furnaces, where we pelletize the iron ore. We typically use gas as the reductant. So we break the methane or the gas into hydrogen and carbon monoxide. We pass that reduction gas over the iron ore pellets. And the carbon monoxide, when it oxidizes to CO2, provides the heat. And then most of the oxygen is carried away by hydrogen. We can potentially tweak that process and make it 100% hydrogen if there's an external heating source. But on just the base kind of direct reduced iron, we can also use, depending on the type of process that was built, we can use CCS and potentially very high capture CCS. Moving out through time, beyond hydrogen direct reduced iron, there's potential to use electrolysis to directly separate iron ore, but we're probably looking at the late 2030s to early 2040s before we see a lot of penetration of that. Now, to make it simple, the short version is more material efficiency, more high quality recycling, get the copper out of the scrap, switching from coke to hydrogen for reduction, and CCS. One projection of a successful net zero transition for steel can be found at netzerosteel.org. If you look at the top left there's a projection for global steel demand rising from just under 2 gigatons to over 2 gigatons. The red is blast furnaces. They're all transitioned out by 2050. The yellow is secondary recycled steel going from roughly 25% to 50%. And then the remainder, the shades of light green are different technologies for reducing iron ore to elemental iron. If we look at the regional pictures all look quite different, however. So if we look at China just to the right, you see demand has come down from just about a gigaton to roughly 600 megatons. The blast furnaces are gone. There's quite a bit more recycling, and there's clean primary iron ore reduction. India is the reverse picture, where demand goes from just over 100 to over 350 megatons. The blast furnaces are gone. There's some recycling, but it's mainly new clean primary or potentially imports of clean steel or clean briquetted iron that allows it to produce the steel that it needs. The European Union kind of peaks, does more recycling. The United States keeps on growing a bit, mainly recycling with some clean primary. But what I'd like to draw your attention to is Nigeria, Pakistan, and Indonesia on the bottom left there, where demand goes from almost nothing to very large and substantial amounts, just for basic building of energy, transport, sanitation, water infrastructure. We need to find clean means for these countries to make steel, for them to carry on their basic development. Moving on to cement, the primary demand for cement going forward is likely to be mostly outside the OECD, China coming down a bit, India growing, other countries growing. And how do we make cement and concrete, and how can we make it with near zero emissions? Well, first of all, how we make it, if you start at the top left there, we have raw material extraction, which is mainly limestone. That is heated to 800, that is ground up and heated to 850 degrees Celsius. It separates into calcium oxide and CO2. That's where most of the emissions from making concrete are. That CO2 is released to atmosphere today. That calcium oxide is baked in a rotary kiln along with iron and aluminum silicates into clinker, which is the raw material for making bagged cement, which is what holds concrete together. It holds the sand and stones and concrete into the form that we know and love, that kind of holds our civilization up. And then it goes off to its various application, be it ready-mix concrete, on-site concrete mortars, or prefabricated elements. Now, how do we decarbonize that? First, and this is the one I found one of the most interesting digging into this, is that a 25 to 75% reduction in emissions can be had by implementing design for material efficiency, so minimizing the amount of concrete we use in buildings, and just making better concrete, mixing it better so that we minimize the amount of cement holding together the sand and the stones, the pore space. So you can make a wall that's a foot thick or 30 centimeters thick or 15 centimeters thick, and it can be just as strong if it's better mixed. Next, we have cementitious material substitutes for the clinker. Most of the emissions come from clinker. We can use fly ash, blast furnace slag, limestone filler, some natural materials. But the key thing here, the key technological advance here is the use of limestone calcine clays, where you use 1/3 ground limestone and 2/3 heated clays together, and they can replace up to half the clinker with virtually no change to the concrete. Just application of this known and approved technology, which meets building code standards across the OECD, would cut the emissions of this sector by 40 to 50%. However, we're still going to need clinker across both the developed and developing worlds. And if you're making clinker in a kiln, you're going to have process emissions. And if you have process emissions, you're going to need carbon capture and storage. And this is where the largest costs impose themselves. Everything else I've talked about here costs roughly the same as making concrete the normal way. Using carbon capture and storage to decarbonize clinker production could double the cost of the clinker, not the concrete, but the clinker. And so first we have to make sure this technology works, we have to commercialize it, and then we have to disseminate it across the world one way or the other. Fourth, out on the horizon, there are new methods that directly access clinker components, the calcium oxide that we need, using acid leaching potentially, which is the brimstone technology, or electrocatalytic methods, which is the sublime technology. The brimstone in particular can be potentially negative emitting if you start with certain types of geology, because the waste materials start absorbing CO2 from the air. But it's going to be some time before these technologies are universally available globally. Now for some combined strategies for a local policy package. First, a multi-level policy commitment to transition to net zero GHG industry is needed at all levels. Then we need building code, design, and recyclability policies for material efficiency and circularity. A transition pathways planning process, including all key stakeholders to assess strategic and technological options, competitive advantages, and uncertainties. We're going to need accelerated R&D and commercialization, lead markets to build economies of scale with green procurement. This is something the OECD countries can get on right away. IDI in particular is active in this area. Content regulations, supply chain branding, guarantee pricing, and output subsidies. So for all the clean iron and clinker we make, we could be offering contracts for difference today, where for every ton that comes out, there's a set subsidy for a certain amount of time, and this can be done by reverse auction to minimize the costs, much as we do for offshore wind. We can do eventual exposure of all sectors to full greenhouse gas pricing with competitiveness protections. If certain jurisdictions start imposing very strong climate policy that requires expensive investments, you're going to need protection for those investments, or dirtier imports will just come in. But we have to make sure that those competitiveness protections don't penalize highly traded green commodities, and especially don't penalize developing countries that are just embarking on their industrialization journeys. And we might need early retirement if necessary for long-lived, highly GHG-intense facilities. And we're going to need supporting institutions as well for monitoring, for electricity, hydrogen, and CCS infrastructure, for life cycle accounting, regulatory backdrop, and firm and workforce education. Now, the question is, what makes this a just transition? How do we build a just transition into this package? We need to involve communities and local workforces from the beginning, make them part of the solution finding process. We need to focus on clean brownfield developments where possible, highlighting the employment and improved water and air quality benefits. One of the things that's not talked about enough is if we move to electrification use of hydrogen in heavy industry, you use a lot less water and you have dramatically better local air quality because you're just not using as much coal or natural gas. And you don't need the water for thermal applications. We're going to need global cooperation on technology development to commercialize and bring down costs as fast as possible. That's going to require clear global rules for benchmark standards for green materials and intermediate inputs, which will allow us to create global markets for green materials. We can imagine a green clinker and a green iron exchange appearing in London or maybe in Johannesburg or Shanghai. We want to concentrate strategic capital from northern countries for clean projects with time-limited, upfront, and ongoing market-friendly lead market subsidies like contracts for difference for production and sales in developing countries. We want as many of these early developments as possible to be in developing countries where the growing demand will be and to prove feasibility to the finance community to make this more of a normal market practice. In summary, a fair transition to net zero industry is possible, but will require planning as well as subtle, staged, stringent, and fair policy. I thank you very much for your time. If you'd like to do further reading, I offer some source papers here. Please do contact me in my email or Twitter, XDM below. And I wish you all an excellent conference. Again, thank you very much for your time.
I'd like to thank Dr. Bataille for his comprehensive presentation. I think his presentation will set out the complex challenges and opportunities we face today for the decarbonization of the industrial sector. So now let's turn to the panel discussion. So we have 4 panel members today who are working on industrial sector and decarbonization. Yeah, you can see here the 4 panel members. Let me introduce the members firstly. So I'm Mr. Amin Farti, Product Development and Quality Control Executive Manager, EZZ Steel from Egypt. Hi, Ayman.
Hi.
And then we have Ms. Kanan Derinos Janan, Director of Environment and Climate Change Department of the Turkish Cement Manufacturer Association. Hi, Kanan, good morning.
Good morning, hello, and good afternoon to you all.
And we also have Mr. Thomas Gill, Chief Executive, Global Cement and Concrete Association. Hi, Thomas.
Hello, gentlemen. Good morning, good afternoon.
And we also have Mr. Hitoshi Donomae, Chair, International Environmental Strategic Committee, the Japan Iron and Steel Federation. Hi, Hitoshi.
Hello, everyone.
So, first of all, thank you very much for joining today's panel discussion. And I know that in European time, it's very early morning, so thank you very much for joining. So I'm going to ask these panel members the 4 key questions for today's discussion, namely GHG emission measurement and the data collection and reporting. And second one is finance and incentive to address green premium. And third question is technology and R&D. And fourth question is about the international partnership. So let's begin by the first question on the GHG emission measurement and data collection and reporting. I'm going to ask this question to Ayman and Kanan. So this question is like, what is the ongoing initiatives and practice on measurement of GHG emissions and data collection and reporting? And what is your view on internationally harmonized methodology, standards, ensuring robustness, transparency, and comparability? So let me ask firstly to Ayman. So Ayman, if you are ready, could you please give us your views on this topic? The floor is yours.
Thank you, Mr. Chairman. Thank you, Mr. Chairman. I would like to thank you for this opportunity to share in this event and the great event for climate that already discuss the climate change and try to improve our climate and the atmosphere. I'm Ayman Fathi from ICEF Steel, the largest steel producer in the Middle East, with about 7,000 million tons of steel production in Egypt. Actually, the steel industry recognized the importance of addressing greenhouse gas emission and has been implementing various initiatives and practices to measure these emissions and improve data collection and reporting. There are some ongoing initiatives and practice in the steel industry regarding GHG emissions. Carbon footprinting, for example, many steel companies right now conducting carbon footprinting assessments to quantify the GHG emissions associated with their operations. This involves measuring emission from various sources, such as direct emission from steel production process itself, or from indirect process like emission from energy consumptions. This already standardized based on ISO 14067 greenhouse gas carbon footprint of products requirements and guidelines for quantification. Also, ISO 14404 series of standards for calculation method of carbon dioxide emission intensity from iron and steel production. Not only, but also there is another initiative for emission inventories for the steel companies. The steel companies developing comprehensive emission inventories to track and monitor their GHG emissions over the time. This includes collecting the data on energy usage, process emission, waste emission, and other relevant factors to calculate the total emission from their operation. According to ISO 14040, Environmental Management Life Cycle Assessment, LCA, requirements and guidelines, also ISO 20915, standard of LCI for steel production. Another initiative for what's called reporting framework. Many steel companies follow internationally recognized reporting frameworks, such as Global Reporting Initiative and the Greenhouse Gas protocol, what's called the GHGB, or the Carbon Disclosure Project, CDP, to report their greenhouse gas emissions. These frameworks provide standardized methodologies and guidelines for measuring and reporting emissions. Other efforts are going and done by industry collaboration, Steel Industry Association, and organizations like the World Steel Association are working together to develop industry-wide initiatives and the standards for greenhouse gas emission measurements and reporting. This collaboration aims to share best practices, establish benchmarks, and derive continuous improvement in emission management. Last but not least, transparency and stakeholders engagement. This technique for steel companies are increasingly engaging with stakeholders, including investors, customers, and the communities to disclose their emission data and the sustainability efforts. Such practices involve publishing EPDs, environmental product declaration for steel products, and producing sustainable construction steel. This transparency fosters accountability and enables stakeholders to make information decisions related to company environmental performance. More or less, we are using the list standards in the steel industry even to control and management of energy consumption through the ISO 15001 to monitor and management the energy, to control even the to optimize the steel energy use, or the energy use in the steel industry to improve the how to use emission in the steel industry. Thank you.
Thank you very much, Ayman. So let me ask the same question to Janan as well. So Janan, could you kindly provide us with your thoughts on this topic?
Yoshi, Ayman introduced most of the standards available. Most of them are voluntary and most of them are mandatory. It's the same in Turkey. In the end, you can calculate emissions or you can measure them, but in the end, you have to report them. For measurement, there are some measurement continuous emission measurement systems. You can establish them on the stacks, but there is a level of uncertainty for some regimes and they cannot meet the requirements and they have to be calibrated. So I can say that calculation is the most widespread method at the moment, but in the end you prepare reports. And yes, these reports are not harmonized and they are not comparable, but I noticed that in the past, past years, most of the stakeholders believe that these reports are one size fits all. They believe that one report can be used for another or they can be used interchangeably. But in fact, it is not the case. The scope is different. The aim is different. Yes, harmonization, I think it is really required because, as Ayman told, it is the same in our country. Our producers have to prepare many reports for many purposes. And believe me, most of the government person, authorities or stakeholders don't know that they are different than each other. Let me give an example. It's a very hot topic, the European Carbon Border Adjustment Mechanism. In fact, we have a mandatory system in Turkey. It is very similar to EU monitoring system. All plants have to report it and verify it. And as Ayman told, we have ISO 14064, and most plants also use this. And for example, our mandatory system covers only scope 1 emissions and only the plant. Also, ISO 14 system covers the plant, but all emissions, scope 1, 2, 3, 4, 5, 6, the new version. But when it comes to the EU CBAM, they cover goods. The system covers goods, not the plants. And the system also covers Scope 1 and Scope 2 emissions. So all the names of the reports are greenhouse gas reporting, but the scope is different and aim is different. And in the end, the European Union published another guideline for calculations. So for harmonization, the aim of this reporting should be clearly defined, for which aim this report serves. For example, also UNFCCC has reporting systems. They are reporting for countries, and these reports mostly can't be used for sometimes scientific studies, for sometimes industrial studies. Let me give another small example and close my views. For example, UNFCCC reporting related to cement, the process emissions are accounted in a different section, and the energy emissions are under energy section. But glass, ceramics, and cement emissions are under one topic. So nobody in the world, when they look at the reports, extract the energy emissions of the cement sector and publish it. And when we talk it to our local authorities, they say, no, we cannot change it because the auditors of the UNFCCC want to do it in this way. There are many reports written for Turkish cement sector and for many cement sectors, and they cannot see the energy emissions of the cement sector. So there are many details, but they have to be solved also. So I believe harmonization will ease the lives, but before the purpose and the stakeholders should understand what to be done and what has to be required for this harmonization and comparability. And in the end, of course, verification is an important step. And let me stop here. Thank you very much.
Thank you very much, Janan, and thank you very much for Ayman as well for sharing a very important your experience on the GHG measurement and also the methodology and standard for the harmonized the way. It is interesting to see the challenges in Egypt and also in Turkey. So before talking about the technology and R&D, let me ask the question about finance and incentives. Question to Hitoshi and Thomas. So, for example, what do you think? What the incentive scheme you received, or do you prefer to have, or what kind of incentive skills are necessary to promote and accelerate industrial decarbonization and green premium? And what will be the, in your view, what will be the effective enabling conditions for boosting green production? So let me firstly ask Hitoshi. So could you please share your thoughts on it?
Thank you very much, Toshi. My name is Hitoshi Donomai. I'm going to talk about the situation of steel industry on behalf of the Japan Iron Steel Federation. First of all, I want to emphasize the background of the issue based on the talk of a plenary speaker about the steel making process. He emphasized that the process change is the key to decarbonize the steel industry. Yeah, maybe you know, we have been used coal to make steel, so we have to change to use coal to use hydrogen. So hydrogen steel making is very important for the decarbonization of steel industry. But I want to say that first, it takes time. It takes time. He also said that it will be realized in 2040 or 2030, he mentioned, but I don't think it will not be realized in 2030. And I also wondering if we can establish the hydrogen steel making in 2040, because just we initiated the research and development stage, and we have never realized the commercial size hydrogen steel making process. First, we have to invest, we have to R&D, and then after we establish the new technology, we scrap the present steel making process, and then rebuild the new steel making facilities. Maybe you understand it takes a long time because iron steel sector depend on the very large size of steel making facilities. And first point is time, and second point is cost. As I mentioned, that we have to develop, we have to rebuild the process. It is necessary to invest a huge amount of money. Yeah. So if we take all those costs by ourselves, we will bankrupt. So first, I want to say that it is a social cost to decarbonize industrial process. So all society take the cost equally. Yeah, first point is that that's so. So in that sense, we ask our government to subsidize R&D cost, capex, and also opex. Of course, public procurement is very important to be supplied, but those kinds of subsidies we cannot get. We cannot continually get those subsidies eternally. So finally, we have to ask our customers and society to realize and respect green premium and pay the higher cost to buy the green steel. But in this sense, it's also difficult for the time-consuming because of this is a time-consuming process. But most of the some of the customer ask us to provide zero carbon or near zero carbon green steel. But as I mentioned, that we cannot supply those kinds of ultra green steel products now. So we are now trying to implement new scheme, which we call mass balance method. The mass balance method is that first we, steel company, reduce carbon dioxide emission from a steel making process. Then we collect the carbon dioxide reduction as a credit and pool into an account, and the credit will be attributed to some kinds of certificates, and we will sell steel product with the certificates. So the customer will be able to deduct carbon dioxide emission by using the certificate. Yeah, in the present transitional stage, it is the only way to return our investment from the society. So, finally, I want to emphasize that the carbon dioxide emission reduction is the most important point to address the global climate neutral society. So we want to all the members of the society to pay for the green premium. Yeah, thank you very much.
Hitoshi, thank you very much for sharing your thoughts, which is super interesting. And I totally agree with you. There are issues of time and cost to apply and develop the decarbonization technologies, and there's also the necessity of kind of awareness raising of consumer side as well to stimulate the demand for the green steel or cement. So let me ask the same question to Thomas as well. So Thomas, if you are ready, could you share your views on this as well?
Thank you very much. I'm delighted to be with you. I'm in London actually, so hello from London here. Listen, maybe a few words of what we have done in the Global Cement and Concrete Association. So we represent about 80% of the cement industry globally outside China, and we have also some key Chinese manufacturers as part of our membership. What we have done is a roadmap showing on illustrating how the industry, the sector can go to net zero by 2050 with some intermediate objective as 2030. And this roadmap shows, various technologies, which are pretty much very in line with what Professor Bataille illustrates at the beginning of this session. And why I'm saying that, because I think the first thing that we need for financing is transparency, and that's also reflect a little bit on the first question you had, giving numbers, monitoring, having an understanding of what technologies are there to go to net zero, what technologies are there to decarbonize or to do low carbon, because it's different to be low carbon and to be net zero. These are not necessarily the same technologies. And I think for me, this is really an important part to make sure that, when we talk about decarbonization, we really understand what works, what doesn't work, what is scalable, and what is the expected cost of that. Of course, with some uncertainties, innovation plays a role. We will make it faster, we will make it cheaper, thanks to innovation. But already today, we have a lot of ways to actually get to net zero, but this needs to be understood. Taxonomy. Taxonomy, there is a keyword for the financing world to understand and to, have a little bit of a nomenclature of where to bid. I think there was one very important exercise done by UNIDO, actually, and I'm not saying that because this session is organized by UNIDO, but because the IDDI initiative was really, in my view, essential to characterize and to explain what is a low-carbon concrete, what is a near-zero concrete, and how these things can be articulated globally. So we have there an international, a universal nomenclature that enables people to understand, what they buy, and have clear rule, clear system in place to read that. And I think these type of things are very important because based on this, you can actually dictate or you can propose demand signals, and these are the procurement on because you have such a scheme, the demand can be actually structured in a way that say, okay, look, I want to organize my demand as a state procurement to facilitate or to give or to push to foster the development of this and that product. And for example, I was saying low carbon versus near zero technology. A country, and that's what happened, for example, in United States, in some of the states, can say, well, as of a certain moment in time, and we are back to the notion of time from Hitoshi, I will only buy clean material. So that gives you a number of years to actually change and adapt your technology and say, well, as of 2035, for example, I will only buy net zero cement, net zero concrete. Similar to what the European Union has done with the electrical car, for example. They say that as of 2035, you are not authorized to put in the European market cars that are based on old technologies and that are based on carbon technology. So these are really a first part of element, or two part of element, which are important for me for the financing discussion or the financing model. Transparency in a scheme and creating the demand and enabling a demand to be structured around a certain scheme. Now, I think we have also to consider, the risk involved. There is technology, there is substantial investment to be rolled out. Professor Bataille explained that very well. And I think there we have to look at, how to accelerate time, how to make sure that investors, have the incentive to read through that and to actually dedicate money in making the transition happen, right? And this is all the discussion on de-risking, on what are the risks. The risks are around, the legislative process. So, when the European Union or where the Americans are talking about simplifying the permitting process, that's an important factor. We heard in Texas, I think there was two big carbon pipeline that were actually challenged from the permitting process. That's a problem for investors. We have also all the discussion around financing risk on there. I mean, all the mechanism, the classical mechanism through green bond, through syndicated loan, through guaranteed loan, etc. I mean, these are things that facilitate also on de-risk the investing on the financial risks for the sector, and these are important part. I think we have also element on the operation itself. On there, the essential part for me is give a price to carbon, right? Carbon pricing is a very important part of the discussion. I mean, some people talk about green premium, people talk about different solutions, but we need to give carbon a price. I've seen in Science, there was a review that was demonstrating that the societal price to remove carbon from the planet was around $180, right? We are far from that in all countries, even in Europe. With a very advanced CO2 pricing system, we are way below that numbers. But at $100, like it is, or 80 euro, in between 80 and 100 euro in Europe, you can still decarbonize things, and you can make projects on these schemes in Europe and in USA with the IRA. Gives you a very interesting framework to invest into these new technologies. And what they are doing, in fact, they are suppressing, they are killing, they are deleting what we call the first mover disadvantage, because today that's the thing. It's the first mover. You have a disadvantage if you don't have the schemes behind that give you this thing. Because let's be honest, near zero material will never compete against a classical material. You have a cost of decarbonizing, and this cost is the cost of carbon. So I think that there are some really important things to de-risk, and I will just name a few. I mean, the first one are the contracts for difference. Which basically guarantee you a certain carbon price, even if the volatility of the carbon market price is actually fluctuating on below your abatement cost, the cost of your technology. Of course, cost of carbon comes with carbon adjustment. I mean, else you will just export your carbon emission. That's not what we want. And another example also would be, I would call the zero emission credit, right? So this is something where you can actually trade the emission credit. So assume that you have a removal technology, not just offset, etc. It's not about offset. It's really emission credit, zero emission credit, removal technologies that can be then tradable, and that facilitate probably the development and dispersion of the projects around the geography, around the economy, etc. And making sure that you leverage at the same time and concomitantly all the opportunities of investment that you have, starting with probably the cheapest. We talk about carbon capture, use and store. You have places that are closer to the storage. You have places that are, in areas where storage are already developed. We need to leverage this place, even though they are not into a regulated carbon area. So that's an important opportunity, and especially for commodities like cement, 80% of the consumption, of the production and consumptions of cement is outside of Northern Europe and Americas, Northern America, right? So we need to understand how we can help the South, Global South, as we call it, to elevate and to actually go and embrace the transition through this type of financing schemes and financing models.
Thank you very much, Thomas, for your valuable insights, and also thank you for touching upon UNIDO's IDDI. I particularly found interesting about that you mentioned the importance of de-risking of investment, but because that issue for UNIDO as well, when we develop the project in emerging and developing countries, we always face that problem when working with a private company. So yeah, that's absolutely one of the most important issue we need to think about and discuss and try to solve the issue with the government and the private sector. Thank you very much. So let's move on to next topic on the technology and R&D. So this question is to Ayman and Janan again. So what is the technology development and uptake ongoing and expected towards decarbonization from your experience? So let me ask firstly, Ayman, this question. So could you kindly share your thoughts on it? you're muted. We cannot hear you.
Okay, okay, are you hearing me now? Is it okay?
Yeah, we can hear you. Please go ahead.
Okay. Actually, before even starting to list some of the new technologies in the steel industry that already developed or undergoing to develop for producing steels with friendly production process, what's called green steels or something like that. Let me tell you that in 2022, the world produced around 1.9 billion ton of steel for different uses, from construction, from home appliances, from automobiles, transportations, pipelines, for each and everything you need in our life. So this 1.9 million ton of steel was a very high investment. Already responsible about I think $1 trillion of investment, and thousands of workers in this industry. So it's very important to develop a sustainable process for this industry. 1.9 million ton of steels producing around figure 1.8 specific carbon ton carbon emission based 1 ton steel. So you can imagine how it was the carbon emission dioxide from average quantity produced due to this total production of steels. Hence, the carbonation of steel is fatal to meet not only the climate mitigation targets, but also to achieve sustainable future of the industry. Let me tell you that the steels, as Dr. Bataille said in his presentation, that the steel is produced by two main routes of production. The two main routes of production is blast furnace, basic oxygen furnace production process, and the other process is electric arc furnace production route. The blast furnace, basic oxygen furnace production route is about 73% of the production all over the world, responsible for that. And the 27% is through electric arc furnace production process. The basic furnace and the basic blast oxygen furnace production route, depending on the raw material, iron ore oxide, and carbon materials that reduce oxygen from the material, coal and other carbon material to reduce the oxygen from the iron ore through blast furnace. And then later on introduce oxygen to decarbonize the produced iron ore, and hence CO2 emitted to the atmosphere. All the technologies introduced in the last 10 years to improve the process in this process is only able to reduce from 10 to 30% of CO2 emission in this industry through this blast furnace production route. The other route of electric arc furnace depends on the electric energy that already introduced through graphite electrodes to charge basically from scrap or from direct reduced iron. The direct reduced iron is a iron ore, but reduced, that already increase the iron with the metallization of the material through reducing the oxygen from the iron ore itself in solid state process through natural gases through natural gas cracking to 70% hydrogen and CO2, 30% CO gas. 88% from the emission come from the steel industry. Let me tell you that 8% of the whole CO2 emission in the world, only 8% come from the steel industry. Out of this, 88% come through the blast furnace route, and the other 12% is coming from the electric arc furnace production route and through scrap using or DRI and scrap usage of. Many technologies have been introduced for the industry to reduce the emission, especially in the road with high intensive CO2 emission, like basic blast furnace and basic oxygen furnace. When you know that about 2.3 ton of CO2 per ton steel produced through basic oxygen blast furnace and basic oxygen furnace, when we introduced increased process efficiency through process control and automated process control, it could be reduced 15% of this emission, and the emission was limited to 1.9 ton per ton CO2 per ton steel. Also, a biomass input introduced to substitute some of the coal input with emission reduction around 50%. This helps to reduce the emission of carbon dioxide from the process itself to 1.1 carbon dioxide per ton steel. Also, introducing the carbon capture usage to the blast furnace and the basic oxygen furnace. This road use natural gas to reduce. This road capturing the CO2 gas from the blast furnace of an integrated steel plant, and they reduce overall emission by 60%. So we can reduce by using carbon capture storage the CO2 emission to 0.9 ton carbon dioxide per ton of steel. Introducing the direct reduced iron or increasing the direct reduced iron technology to the process, there is too much challenges for using direct reduced iron because it needs high quality iron ores besides natural gases. It needs special requirements for production from raw material and the natural gases. This road uses natural gas to reduce iron ore, which almost half emission of the CO2. They accounts for 5% of current world production only. They reduce the emission to 1.1 carbon dioxide to ton steel. Using or recycling the scrap through electric arc furnace is the best technology to reduce emission. It only emitted 0.4 ton carbon dioxide for 1 ton steel, but it needs to have enough scrap to be recycled and to be good quality of scrap to reduce carbon emission. Also, to reduce the carbon emission through technology, we need the zero carbon electricity, which is up till now it's too much expensive to have, and the electrolysis process to produce green hydrogen for new electricity production is still expensive, but still its way to work. With zero carbon electricity for electric arc furnace, by using zero carbon electricity, near all emission from steel making can be eliminated to 0.1 through electric arc furnace production route. Actually, nowadays, the trend of producing DRI through by using hydrogen from different resources, which is gray or blue or green hydrogen, are increased because of this production route is a very or a high effective route of reducing carbon dioxide emission. So nowadays, many projects in Europe, especially in Europe, are introduced for reducing green steel through reducing green DRI by reducing DRI by completely using hydrogen instead of using a mixture of hydrogen and CO. These new technologies will help in future to reduce emission of carbon dioxide in the steel sector by half of quantity, but it needs a long time to spread the technology to improve the raw material quality to be used later on in reduction process in DRI process. Also, there is many trials to use green hydrogen in blast furnace, but the process itself, the technology itself, face some problems because we cannot replace all the carbon in the blast furnace by hydrogen, because hydrogen reaction with the iron oxide is endothermic reaction, which is limiting the use of hydrogen, because using too much hydrogen will reduce the energy in the blast furnace, will reduce the temperature of the process, which is very effective to the production of molten steel by this process. Actually, the new technologies, I can summarize the new technologies now in blast furnace efficiency for improving the efficiency by using optimizing the process by using process control methodologies and automation, using also biomass reductants, use biomass as an alternative reductant of fuel, carbon capture usage to capture the CO2 and later on produce bioethanol production from CO2 emission. Electric arc furnace, as I mentioned, to maximize secondary flows and the recycling by melting more scrap in electric arc furnace. DRI plus electric arc furnace usage natural gas, increased uses of DRI in the EF will help to reduce the carbon emission. Using hydrogen technology or green hydrogen technology to reduce iron ores through DRI, directly used iron process, is already now proven technology and already in some plants in Europe and Middle East are already built for this production type of road. Another technologies are introduced for different category of process, like the technology of thin slab casting, that using steel directly from molten steel to produce final product directly from molten steel, thin slab casting and rolling to reduce energy consumption and hence reduce emission through reducing energy consumption. The direct rolling and the twin rolling is also helping to reduce energy consumption and reduce the energy, the carbon emission from energy consumption. I can also mention here that there is many trials to produce special steels that with special properties that already will help to reduce the quantity of steel used and improve the quality of steel. Improve the quality of steel, the characterization, the mechanical properties will help to reduce the quantity produced and the quantity used by using special steel grade with special qualities. In, for example, the advanced high strength steel for automotive application is already helping to reduce the quantity of steel used in the automobiles by using high strength steels and such kind of steel, which is reducing the energy consumption by reducing the quantity used and the quantity produced for such kind of application. There is another many small projects and research and technologies already going on to reduce energy by reusing the exhaust gases in oxygen converter and in electric arc furnace to be recycled and to be used to reheat the charge in electric arc furnace, or to use the gases to in another process to reduce the carbon emission. Thank you for your attention.
Thank you very much, Ayman, for sharing your insightful comments on technology, including green hydrogen and carbon capture. So let's now ask also Janan on this topic. So Janan, could you please share your views on this?
Thank you, Yoshi. As the Turkish Cement Manufacturers Association, we represent more than 95% of the production in Turkey. As a sector association, we also prepared the roadmap with a consulting company. It's an internal document. We did it a few years ago, and we distributed it to all our members. And also we review all the roadmap of GCC, the SAMIRO, and the United States and the UK. These all conclude that in this changing world, you should make a low carbon production. And I will try to keep it short. There are conventional methods, as Dr. Bataille told in the introduction. As long as you can find finance these, or you can overcome the legal barriers, you can realize these conventional investments. But the problem is the technology development side, the unabatable emissions side, and this is specific to cement sector. Even you reduce emissions by energy efficiency or biomass-based alternative fuels or clinker substitutes, there is an unabatable emission. There are a few methods for this. One is capturing this carbon and using it somewhere as a product, or storing it somewhere. And maybe you can change your fuel. You can use hydrogen as fuel. In a country like Turkey, we are a developing country, we can say we have almost nothing in this area because finance and technology development always goes hand in hand. But Tom and Hitoshi told about this, Hitoshi told a lot on this issue, so I won't get into details. Technology development is required, especially for unabatable part. Of course, technology development is not enough alone. You should prepare the legal framework. These technologies should be inserted in all the regulations and laws in a country, and there should be people who knows these technologies. Someone should prepare projects and apply these projects on site and operate these systems. I'm sure it's the same in most of the developing countries, and and of course, funding is not enough at the moment. As Türkçimento, the representative of the sector, we are trying to make some additions to this system. We are trying to finance or co-finance some, at least research and development projects, maybe some pilot projects. So we hope to disseminate this know-how to all our members. And the aim should be to develop this technology in our country instead of paying for this for some time later. So we are trying to build up this capacity in our country. Thank you very much for this moment.
Thank you very much, Janan, for your valuable comments on the technology and resource and the development. So let's move on to our final question, which is on international partnership. So I will ask this question to Hitoshi and Thomas. So in your view, what do you think, what are the roles of international partnership to accelerate decarbonization market in cement and steel industries? So let me ask firstly, Hitoshi. Hitoshi, please.
Okay, thank you. Thank you. Yeah, as I mentioned about the decarbonization of steel industry is very, very challenging. But to tell the truth, there are low-hanging fruits for all the world steel industry to reduce carbon dioxide emission. Because Japanese steel industry have already established the most energy efficient steel making process, which means that our carbon dioxide emission per ton of steel production is lowest in the world. Because the Japanese steel industry have developed energy saving technology, a lot of energy saving technology, and we have already installed all the kind of state-of-art energy saving technologies in our steel production process. So it means that there are many potentials for the other countries in the world to reduce carbon dioxide emission in their steel making process. So the Japan Iron Steel Federation have conducted international cooperative initiative to disseminate the Japanese energy saving steel production technology and instrument to, especially for the emerging society. The partner countries China since 2005 and India 2011 and Southeast Asian countries since 2014. We have a special 3 tools. First one is the public-private forum to exchange views and introduce the Japanese energy saving technologies to the countries. We conduct the forum basically once a year. And second tool is the energy saving technology list, which is customized for India and South Asian countries, which for example, for the payback time depend on the each country's special circumstances. And the third point, third tool is steel works diagnosis. The Japanese experts go to the steel works of the countries, and then we diagnose the energy consumption situation, and we introduce the specific way to reduce to saving energy, and we introduce the specific instrument to reduce energy consumption for fitting each steelworks. So we have been conducting that kind of activity for more than 10 years, but now the steel demand will increase more and more, continue to increase year by year. So, but in this decade or 2 decades, there are no no carbon neutral technology like hydrogen steel making. So the most important and concrete measure is to introduce or implement that kind of energy saving technology to all over the world. So if you are interested in our activity, please contact the Japan Iron and Steel Federation. Thank you.
Thank you very much, Hitoshi. Thomas, could you also share your thoughts on it? Thank you.
Sure. Yeah, with pleasure. So I had an alarm here in London, so fire alarm. So I was a little bit off camera for a second. To answer your question very quickly, I mean the role of international collaboration is essential. Essential not only to get things done, but to, as you said, accelerate the things. And I would like to illustrate it through a few examples. First, on policy. I mean, we all agree on we know that policy is an essential part of the discussion of the transition. We need to convince and we need to put in place systems that allow and will enable the development of technologies, the deployment of assets, etc. Mr. Bataille was illustrating on citing the technology of circularity. I mean, you cannot create a circular model if you do not have a specific legislation in place. And for that, typically, global cooperation is essential. An industry alone cannot, organize on have this discussion at a trustful level with government or very difficult. So I think the global partnership on there, for example, the breakthrough agenda, which started in Glasgow on cement and steel are both a chapter of this breakthrough agenda. I think are really essential platform to collaborate on to make sure that between countries you have this trustful discussion on, look, this is something that works, that's a technology that will decarbonize. These are things that you can, guys, implement and you can trust the model can be implemented in your country, so that there is a discussion on experience, sharing of experience from peer to peer, from country to country in discussing. We have other example on that, the carbon management challenge launched by the Americans, the American government around CCUS, on the deployment of CCUS technology. That's another interesting platform. The carbon pricing challenge launched by Canada. I mean, I was in New York a few weeks ago with Mr. Trudeau introduced on was actually welcoming additional countries with the World Bank, discussing on what are the right policy on how do you structure a policy around carbon pricing, carbon leakage, always goes together. Very interesting. And these are things that will enable to accelerate and to foster the positive condition. On innovation, this is also essential. I mean, we have to reinvent the way we are working in the cement sector, in GCCA. We have two global platforms that are driven to innovation. One is cooperation on fundamental research with universities. We have 75 PhDs from all over the world, Americas, Africa, Europe, Asia, working on fundamental research on around decarbonization, on capture technologies in cement, on artificial intelligence, on process-specific matters, on product, of course. So 75 PhDs working on things, on upbuilding in a cooperation that covers not only academics, but also industry. So industry comes on finance the research, on help to focus on to foster the thing. We have a second platform with startups. This is a little bit new for a sector, that is not necessarily the reputation of being the most innovative sector, but I can tell you that this is a revolution. All the biotech, all the material, new tech, etc., that is coming, and we have every year a challenge where we have more than 100 startups that comes and present their technologies to the industry. We have the 42 members of GCCA that are actually listening. It's like an innovation speed dating, if you want, and the startup are going on presenting their latest technologies. Same thing on carbon capture, on new product. I mean, this year was about new material for net zero concrete. Very interesting discussion, and you accelerate tremendously the speed of maturation of the individual technologies proposed by the startup. So there again, essential also in the deployment or in the financing of the transition. we have again in New York. I was introduced to a very interesting concept that was called the chain reaction, where it was again UNIDO present. How you can actually convince and help the final investors, the one that will develop enable the transition to be implemented at scale. How do you guide these people and give them confidence that the model, the technologies, the levers are working? First, by having a roadmap. Second, by creating the favorable condition through governmental discussion, explaining that yes, circular model will come. Third, by involving the multilateral bank in doing their duties of financing feed projects, of financing projects that are a little bit more risky, that advance on that are pioneering certain technologies, and then grouping investors on making sure that the finance at scale could be deployed. Very interesting concept. I mean, I love it, but illustrating how you can actually create this chain reaction and make sure that this is extremely modern. This is new way of thinking. This is new way of deploying business, of doing business that needs to radically change, and not only again in mature countries, not only in USA and Europe, but also involving the countries in the global south. I mean, you talk about model in Japan. I mean, yes, I mean the Japanese government through its specific model. The Swiss government has also something similar with this click system, trying to understand and help specific government with bilateral agreements to develop technologies and to help getting this carbon cost off the table and to facilitate the deployment of technology. So collaboration is essential. I think it's new ways of working. We have a role as sectoral institutions. We have a role to play thanks to your forum, thanks to your discussions, to address different people and to say, look, this is possible. We are making it happen. The transition is there. We have a clear mandate, a clear technologies, a clear path forward, and little by little to build on to make sure that projects are taking shape and that these projects get actually advertised, promoted, so that others get idea and that the chain reaction like this takes place. So yes, very important to cooperate, and we thank you, by the way, for giving us the opportunity to build this cooperation and to foster this cooperation for this type through this type of forum on discussion.
Thank you very much for your insightful comments, Thomas. So now we covered all 4 key questions. And before wrapping out this panel discussion, I would like to kindly ask each panelist to make a very brief comment because we almost exhausted our time. So could you, so let me start by the Ayman, please. Oh, you are muted, I guess.
Yes, thank you very much for this opportunity to discuss a very important subject about the climate change and carbon dioxide emission, greenhouse gas emissions. This will, without doubt, affect all our atmosphere all over the world. Nobody is away from this climate change. We see the last few weeks what happened all over the world, from flooding all over the world. This affected by the change in weather and temperature all over the world, and we need to increase our efforts to reduce such emission by different policies or technologies. Both of them are very important, as all of you said today, and give the results about increase incentive for the industry and for the R&D to improve and develop new technologies for the industry in cement or in steel to reduce carbon emission. This needs very big efforts from all of the society and from all the industry and all the organization to support such kind of initiative for R&D, especially for R&D. I stress on that because I know that it's very important. It's very important to support the R&D for improving our situation in industry to reduce the emissions. I will stop that to give the chance for other colleagues before the time.
Thank you.
Thank you very much.
Thank you very much.
You.
So next, Janan, please.
Yoshi, related to the reporting of the greenhouse gas emissions, yes, we need harmonization, and I believe it is essential. But before, as I mentioned, the scope and aim of the reporting should be clarified, and maybe this comparability will help the stakeholders. Coming to the new technologies, the support mechanisms are required, and it is discussed in detail. But in developing countries, the mechanisms are not enough to support even pilot plants. And as associations, as I represent, we believe we have very important roles in developing countries. And one of the takeaways for me is that we should deep dive in these international cooperation issues. Maybe it should be helpful for most developing countries. Thank you very much for inviting us.
Thank you very much. So next, the Hitoshi, could you please?
Thank you very much. Yeah, as I mentioned that it is very challenging for the hard-to-abate sector like cement and steel to go to the complete carbon neutral. So as I mentioned that it is very important for us to for the recognition from the society of hardness to go to the carbon neutral, and also we need a support from the society, and we need a specific scheme to support us. And I also mentioned that international collaboration between our country and other country to reduce carbon dioxide emission from the steel making process concretely. So that's all. Thank you very much for inviting me today.
Thank you very much, Donomaya-san. So Thomas, please.
I mean, I think the main message for me is, I mean, we are now in a phase where we are discussing really about action, how to, get there and making things happen. I think my first message is, when you talk about action on industry that are in the long term, that have long cycle, you need to have a plan. So really, every country of the world should now have a transition plan, a roadmap. I mean, we have the GCCA one at global level, but we need to scale that down to see how we activate the plan locally. What is the plan locally? What technologies can you play? How much it will cost? What policy adaptation needs to take place, etc. And we need to have that also discuss with the government. On there, I really call, I mean, if you have government in the audience, everyone to join the international collaboration platform. I mean, IDDI for the demand discussion, of course, the breakthrough cement for the other things, the challenge, the carbon pricing challenge for the Canada, if you want to go for pricing mechanism, the carbon management challenge with the American government, if you want to discuss about CCUS on all these technologies, and if you want to trust that this model. I was in New York, I repeat it. I mean, I cannot count the number of investors that came to us saying, look, we have money to invest in the transition. We have money to invest into the green reality. This is happening. We say 2020, 2030 was the decade to deliver. We have, 6 years, 7 years, if you count the last year as an action year. We need to get things done now. We need action on the ground. And this action should be, as you have it in the title, a just transition, making sure that everybody takes his share and making sure that these technologies that are available, some of them are not that expensive today, are implemented. It's easy to do. It's feasible with minor legislative change on circularity, on the norm of the product, on future demand signals, and that we discuss and see how we pay for the expensive technologies, which is only for a third of the transformation. So it's not a massive cost as such. It's I won't say affordable compared to the social cost of the carbon. And see how we build that long-term on think the long-term transition of this near zero technology. So really, we need to get the actions on the ground. We need to get things done.
Thank you very much, Thomas. So thank you very much again. And I think there are so many insightful comments made by panelists today. Thank you again for your participation. And please give them a round of applause. Yeah, thank you very much, panelists. So we remain only the closing remarks. But before that, I just want to give you my thought from today's this panel discussion. So there's a common understanding that it is necessary to take actions towards industrial decarbonization, particularly in cement and steel. And we already know what are the challenges and barriers and solutions and possible technology, as mentioned by Dr. Bataille and the panelists. And we need the planning, and local planning and global planning, and also the mechanism. They're based on the data, and we need also for the support from the government, private sector, and several players in this area. And I think the UNIDO as international organizations, there are so many roles that UNIDO should play in this area to further accelerate industrial decarbonization. Not only cement and steel sector, but also other sectors like chemical and agriculture, to achieve net zero by 2050. So let me stop here. We still need the time to the video is ready. Yeah. So let me ask now Rana to provide her closing remarks. Hi, Rana. Can you hear me?
Yes. Hi, Yoshi. Do you hear me as well?
Yes, yeah, and we can see you as well. So yeah, please, Rana, floor is yours.
Great. Well, thank you so much to the organizers of ICEF for also allowing UNIDO to bring this important discussion into the forum. And I regret that I had to actually leave Japan to return to Vienna, and I couldn't be there with you in person. Basically, it's discussions like these, to be fair, that give me hope that we can still make it and help reduce these emissions. Because what we see here is a group of committed partners from the industry specifically that are really looking at this as an opportunity also for keeping business while we are protecting our planet. There's also clear indications from them on what is needed to really help create this market in the future. So what I would like to sort of end this discussion with is more of our commitment as well as UNIDO to work with industry as well as with governments like the government of Japan to actually help these industries to decarbonize as fast as possible. From our side, there are 3 key actions that we are working to bring specifically by COP28. First and foremost is actually getting governments to commit to green public procurement as a means to reduce the green premium for those first movers that are willing to really take the risks associated with these technologies and start the implementation. Second is, and it was mentioned already in this discussion, actually the need for the harmonization of the definitions and the standards. And we know this is a very complex topic, and maybe there is no possibility to reach a consensus uniformly about one standard to be used. But what we are committed to is to come as well to COP28 with a roadmap actually to see how this harmonization could materialize and hopefully get some results before the upcoming COP29 as well. And third action that we are also committed to, because in this discussion globally, while we see that there's quite a lot of momentum and a lot of ideas for implementation, there's certainly a gap between what the countries and companies in the global north are taking and those companies and countries in the global south. And so we will be working on setting up technical assistance facility to help precisely with this first step in the chain reaction that Thomas mentioned, basically getting those plans ready. But of course, plans, I believe in plans, but I think we need also those smaller actions. And these smaller actions are working on the development of a pipeline of projects and also facilitating partnerships between industries. Industries in the north and industries in the south need to work together to optimize also on the resources that each have and help develop in a more just and way. With this, I would like to once again thank all of the partners here, that are joining us as panelists. And again, thanks to the government of Japan for convening this important dialogue. So I'll turn back over to you, Yoshi.
Thank you very much, Rano. So this concludes today's side event. Thank you very much for your. Thank you very much again for all of you who participated in today's session, virtually or physically. And I hope that you enjoyed today's side event, and I hope also that today's discussion will lead to further acceleration of industrial decarbonization. Thank you also for the ICEF Secretariat and staff to support to organize this event, and NIDO and METI. Thank you very much.